Genomics Revolution.
Welcome to Genomics Revolution. This is Ka-Sheng So from the 2019 Hiram College Genetics course hosting this episode on the genome of Campylobacter jejuni, or C. jejuni. The species C. jejuni falls under the Campylobacter Acacia family in the Campylobacter genus. C. jejuni was discovered by Theodore Escherichs in 1886. Escherichs was studying stool specimen and large intestinal mucus correlated to diarrhea in kittens and neonates, and he published his result in the intestinal bacteria of the infant and their relationship to the physiology of digestion. Escherichs would grow culture from infant stool sample, and he successfully identified 19 different bacteria, including C. jejuni. C. jejuni is one of the highest cause of food poisoning in the United States. In 2011, the CDC predicted over 845,000 C. jejuni related illness each year. To look at one particular strain of C. jejuni, strain NCTC11168, it has a circular chromosome of only 1.6 million base pair and two additional plasmids of 35,000 base pair each. Due to how small C. jejuni is, C. jejuni was made into CJ-Cas9 for more efficient CRISPR-Cas9 for use in altering genes. Up to 1,654 proteins are predicted to be encoded for C. jejuni. Something very interesting about C. jejuni is how few repeated sequences it has, with only 4 repeating sequences consisting 3 copies of the ribosomal RNA operon, which are 6,000 base pair in size, and 3 duplicates of some open reading frame. Repeated sequences are important as they could suggest highly preserved sequences, for example, the ribosomal RNA operon seen here. Repeated sequences are also important as tandem repeats aid in mutations. A lack of repeated sequence suggests either slow mutation or mutation through a different method. Which brings us to another interesting fact about the C. jejuni: its inability to perform DNA repair. The C. jejuni do mutate. In fact, some regions shows as much as 3 times more variation when compared with other organisms like E. coli under similar population. The rapid rate of variation suggests that C. jejuni was unable to repair its own DNA. DNA sequencing find that the direct repair genes, ADA and PHR, among other repair genes, was nowhere to be found in the C. jejuni sequence. C. jejuni mutates simply by not repairing their own DNA. Another interesting fact about the C. jejuni is how few operons or cluster of genes there are. Some sets of proteins still operate under the same operon, for example, the ribosomal protein operon. However, up to 617 family of genes are scattered throughout the genome. For example, the tyrosine, aspartic acid, and glutamine can be found scattered randomly. Why it seems to make it difficult to study? On the contrary, it allows us to focus on how important the genes that are grouped together must be. For example, the lipopolysaccharide genes cluster must have been involved in the synthesis of surface structure. Isn't the C. jejuni interesting? Thank you for listening.